Hello friends. Imagine stars so huge, so powerful that they lived only for a blink in cosmic time. Astronomers call them dinosaur stars, the giants of the early universe. Today, we will explore how the James Webb Space Telescope has helped us to uncover their story in a galaxy called GS3073. Just 1.1 billion years after the Big Bang. And we also connect this to the latest James Webb Space Telescope discovery, a runaway black hole racing through space. Let's begin. Before we begin, don't forget to subscribe, like, share, and leave a comment. After the Big Bang, the universe was dark, filled only with hydrogen, helium, and a little lithium. Out of this simple gas, the first stars were born. Astronomers call them population 3 stars. These were the very first generation of stars. Pure, metal-free, unlike any stars we see today. They were extremely hot, extremely bright, and they changed the chemistry of the universe by creating heavier elements inside them. Without population 3 stars, galaxies, planets, and even life could not exist. These stars lit up the cosmic dawn. Slowly, galaxies started forming around them. The James Webb Space Telescope is now giving us the first real evidence of these ancient giants, hidden in galaxies billions of light years away. Among population 3 stars, some were true monsters, the so-called dinosaur stars. They were between 1,000 and 10,000 times the mass of our Sun. Imagine their size, much bigger than any star alive today. But they lived very short lives, only about 250,000 years. In cosmic terms, that is like a blink of an eye. These stars were made only of pure hydrogen and helium, with a little lithium. They were the first generation of light in the universe. And inside them, the building blocks of life were created. Without them, heavier elements like carbon, oxygen, and iron would never exist. Just like dinosaurs on Earth, they were giants that disappeared quickly. But they left behind fossils, black holes. These black holes became the seeds of the supermassive black holes we see today at the center of the galaxies. Unlike normal stars, which end in supernova explosions, dinosaur stars collapsed directly into black holes. This explains how black holes in the early universe grew so fast, much faster than scientists expected. Now, let us talk about GS3073. This galaxy is very far away. The light we see today left it 13 billion years ago, only 1.1 billion years after the Big Bang. James Webb Space Telescope studied its chemical fingerprints. It found unusual spikes in nitrogen and oxygen ratios. These nitrogen to oxygen spikes are not normal. They are signs that supermassive primordial stars once lived there. This is the strongest evidence yet for dinosaur stars. GS3073 is like a fossil bed of cosmic dinosaurs. It shows us how the first generation of stars shaped the universe. The James Webb Space Telescope has revealed something dramatic in another system. The cosmic owl galaxies. They are called so because their shape looks like an owl's face. Here, two galaxies are in the middle of merging. At the center of each galaxy sits a giant black hole. As these black holes swallow gas and dust, they shine brightly, like glowing eyes of an owl. Inside them, astronomers found a runaway supermassive black hole, 10 million times the mass of the Sun, racing at 2.2 million miles per hour. Behind it stretches a tail of stars and gas 200,000 light years long. This runaway black hole is living proof of the violent legacy of those ancient stars. It connects the story of dinosaur stars to the modern universe. This discovery is not just speculation. Teams from the University of Portsmouth and Harvard led a detailed modeling of stars between 1,000 and 10,000 solar masses. Their work, published in November 2025 in the Astrophysical Journal Letters, solved a 20-year puzzle about how black holes in the early universe formed so quickly. The research confirms that dinosaur stars collapsing directly into black holes is the missing piece of the puzzle. So, what happened after dinosaur stars collapsed? They became black holes. These black holes grew bigger and bigger. They joined together and they became the seeds of supermassive black holes. These black holes powered quasars, the brightest objects in the universe. Without dinosaur stars, we cannot explain how black holes become so huge, so quickly. The runaway black hole in the cosmic owl galaxy shows us that these fossils are not silent. Some black holes are hurtled across galaxies, racing at unimaginable speeds, reshaping the cosmos. They are living legacy of the first stars. Friends, let us recap. The universe once had dinosaur stars, giants that lived fast and died young. In GS 3073, James Webb Space Telescope found their chemical fossils. These stars collapsed into black holes, which later grew into the monsters we see today. And now, James Webb Space Telescope shows us runaway black holes still roaming the universe. The dinosaurs of the cosmos may be gone, but their story continues in the stars and black holes we see today. If you enjoyed this journey, please subscribe to Astro 82. Together, we will keep exploring the universe with science meet imagination.